All right, so that's the last sort of practical information point. Now let's move on with our next session. So I have a slightly longer description and framing for this, courtesy of colleagues in the coordination team, because this is going to be the second of the 2 demonstration sessions, but it's going to go into a little bit more specific detail. And more to the point, it's going to look to sort of bridge the gap, or look at how we bridge the gap between the complex climate and weather data produced by the first 2 digital twins and the needs of policymakers, public authorities, and climate service providers. So underneath that rather broad umbrella, we're going to be exploring the questions about how advanced scientific data can be made more accessible, usable, and actionable. And that through the series of user-oriented platforms and services provided by the Destiny ecosystem. And as many of you appreciate, a crucial step in that regard is also around the questions of standards for conforming access and support for data fusion, with a wide variety of information sources beyond the weather and climate domain. So, a few more words of intro, and then we're going to get into the content. So we're going to have a number of short presentations which are going to look at how Destiny has evolved from a high-performance simulation environment with large-scale, high-quality data production on the Euro HPC platforms into an ecosystem enabler for brokers of climate information and services that may have been more used to geoinformation systems data access in the past. So this is all part of the big transition, the HPC environment and the big data. So in that sense, Destiny playing an important role in offering different services around and access pathways to the data that is held under Destiny. So some of the services that we're going to hear about have been designed to support users with different levels of technical expertise. I think that's also been explored in the co-design workshop earlier today. From those requiring direct and fine-grained data access to those who need more intuitive ways to explore and understand the information held within the Destination Earth platform. And so, we're going to look to showcase some examples that enable integration with existing decision support tools and operational workflows. So with that, I'm going to sit down and introduce people who know a lot more about this than I do. So we are going to have 2 main parts of the session. The first will be a series of 4 short presentations, which will be delivered by 4 esteemed guests from my left. So first of all, Adam Ward, a research software engineer at ECMWF. Next to him, we have Ignacy Baez Casanova, who's a physical oceanographer and climate data scientist at Predictia. Next to him, we have Daniele Puchmai, who's technical coordinator for Destination Earth at EuroMetsat, or EU-Metsat, my apologies. And lastly, Claire Billon, who's technical project leader at Gael. So we're going to use their cases as a launch point into a short kind of wrap-up of the co-design workshop that took place earlier today, and that as a bridge into the high-level policy discussions to follow in our closing plenary. So let's kick things off, first of all, with Adam. Please, the floor is yours.
Hello. Hi. I'm Adam. Thanks for the introduction. So I'm going to give a presentation on some of the data access that we provide from ECMWF for all of the digital twins. Just a big thank you to everyone involved in the software here and also help with the presentation. So I will just do a bit of setting the scene, let's say, of basically why we have these different data access methods and why this is quite a difficult problem. So essentially, if you've used maybe meteorological or climate data before, you'll probably know it's quite complex. There's a number of spatial dimensions, temporal dimensions, you've got parameters, you've got different models. And in Destination Earth, this is also a big issue. You've got the extremes DT with 2 time dimensions. You've got very high temporal granularity in the climate DT across a very large date time range. And this then leads to very large data sets, so it's in the tens of petabytes. So this is very difficult to obviously serve to people. A lot of users want the data, maybe at the same time, maybe very large sections of the data from different models. So we're basically looking at ways to make this as easy as possible for users, both make it fast, efficient, and also easy to use. And basically, the data is too big to really cache or maybe transpose. We just have the data itself that's actually stored, but we're looking at different access methods to make it easier for different users to work with this data. And traditionally, this data is stored in these global fields, so that's kind of the base that we'll build off of. So essentially, one of the main solutions for data access that we have at eCMWF is Polytope. So Polytope is a data service that is for efficient access of data cubes. And basically, I'm going to show you how this works with the Climate DT, Extremes DT, On-Demand DT. I should also say we're using this internally at eCMWF to serve our own data. So it's quite easy then to integrate with, say, our operational data. And it's also in the EarthKit framework, which is our meteorological software package for data access, retrieval, post-processing, and plotting. So it's very easy then to, say, interoperate in these different data sets. So what is Polytope? Well, Polytope is a data access service. It can serve data in a traditional way that maybe if you've used our data before, it's global fields, it's GRIB, so you get your bulk data and then you do some processing on it yourself. But obviously for these very large data sets, very high spatial granularity and then also temporal granularity, the Climate DT obviously you maybe want 40 years of this global data that's very difficult to give back. So one of the things now we're adding as a key feature is basically these features. So instead of requesting a global field, you can maybe only want data for your region or your country. Maybe you want to have, look at how a scenario affects maybe shipping lanes, so you can get a spatio-temporal trajectory. Maybe you just want data for your city, how the temperature is changing across a very large time period, or how the wind would affect a windmill. So you can just get that point from the data. We're just pulling out those bytes and giving it back to you for all of those fields. So just an example of how these data reductions work and how much really we could save in terms of this. Here's just a plot of where we're pulling out data for Spain, France, and Italy. And if we got the global field, that would be about 100 megabytes. But here we're getting a 95% data reduction. We're just getting 5 megabytes of data. And this is really nice if maybe you just want that data, you don't want the global field, you get it, and then you cut it out, and you throw away all of those other bytes. We're just giving you the bytes in this case. And maybe an even more drastic example, let's say, is if, say, you just want a time series for a single point for the city you have for 20 years of the Climate DT. If we pull this as global fields, you'd have to pull out almost 700 gigabytes of data. While as with Polytope, you can just pull out a single point for that data and create your time series of whatever parameter you want. And in that case, we're getting a really, really big, basically, reduction in the data, over 99%. And just a little experiment we have of if we took the average European internet speed, how long it would it take to pull all of those global fields versus just using Polytope to pull that single point. And as you can see, it's quite a big difference, although I think that internet speed was a bit slow that we took, so maybe not as drastic. And I should say this is basically not touching disk. You're just getting the data all the way through the system. We're pulling it directly and giving you just those bytes. So I'm just going to show you a few examples of basically using Polytope to pull the data and then some plots that we made. These are all using EarthKit, so it's pulling the data via Polytope, via EarthKit, and then plotting it. But say we want a time series of a city from the Extremes DT for multiple parameters. We can do that. So let's say we pull out Athens. We can see we get the data. You can then plot it across your 2 weeks in a metagram that maybe you're used to if you've used eCMWF data before. You can do that for any city basically in Europe. So just a few examples here. I unfortunately didn't get one for Brussels, which I probably should have done for this plot, but I think there's plenty of other examples. And just to say, all of this data is just created using our software, so it's quite easy to use, and we have lots of examples of that. And I'm running a training tomorrow, which will go through creation of some of these examples if anyone's attending. So then we also maybe want to look at the Climate DT projections just for a given country. We can do that as well instead of a single point, so we can pull out data for, say, France, Germany, Greece, or Poland. And as you can see, it's not just contiguous data. You can also get islands, say for Greece, which is quite interesting. And if you just had a bounding box of that, you'd have to get a lot more data. But with Polytope, you can pull out all of those different islands, basically. And you can see really the granularity of the data here. This is the high spatial data. And then let's say you want to compare then the temperature across multiple years. You can do that as well. You can pull out the data for today, for a year from now, 2030, 2035, and then towards the end of the 2040 decade, and you can just compare those by the eye, or you can do other aggregation on top of these, maybe if you want to create a time series from it. So here's just kind of a worked use case maybe for people who are less on the science side and in terms of interoperability with other data sets, because obviously it's really nice to have this Climate DT data or Extremes data, but maybe we want to combine this with other data sets to get more interesting insights, let's say. So here we can see we're pulling out basically each of the models and then comparing to Era 5, seeing what the changes are, how we compare to historical maybe simulations, and doing that comparison. This was actually made by Arena. It's actually a GIF of all of the member states pulling data from Polytope and then comparing from the historical simulation to the future projections. Yeah, so I think it's just quite a nice example of basically all the countries. Maybe it'll get to Belgium, or it already did, but by the end of it, I move to the next slide. And then again, you can also, this works with the storylines. So here we're taking the Paris simulation that was talked about in the previous session, and we're getting basically the time series of just this data, comparing the different models, and it's really easy to do, just pulling the data that you want. Yeah, and here's just the interoperability with some other data sets. So what I did is I pulled out each of the European countries and got the average 2-meter temperature for each country, basically for the historical period, and then also a future simulation. So this itself is nice. Okay, we can see kind of the change in the average temperature, but maybe we want to get some further insights that can then drive things like policy decisions, or maybe kind of show the public what we can do with this data. So I just pulled some Eurostat data that's also publicly available, plotted it for the percentage of people who are over 65, and then we're doing a combination with basically the historical data and getting a climate hazard. And then we take the future data, we do the same thing, and we get a climate hazard again, and we can basically see the change in terms of how different countries maybe will be affected, which countries are affected more, and maybe we can then target maybe policies a bit more. I should say I made this, and I'm not a climate scientist, so don't take these numbers. It's more of just an example of how we can use the data together. Yeah, and then basically that's Polytope, but then we have some other packages that are basically help use, let's say, Polytope or hook into workflows. So Aviso is our notification software. So what we do here is you can basically ask when data will be available for a certain pattern, and then you can do something based upon that. So the Extreme TT is obviously running on a rolling basis. You want to know when there's a new day available. You can set up a notification for that, and then when that data is available, you can do something with it. You can plot it, you can maybe pull it with Polytope, then you can do some post-processing on it, maybe update a website. So I think this could be really useful to then hook into some of the applications on the platform. And just in terms of, it's quite complicated, the data in general. There's lots of data, very high spatial resolution, also temporal resolution. And just actually making a request can be quite difficult. So we have some catalogs basically implemented, and these are looking at also outside of, let's say, the meteorological domain. So we're looking at OGC, geospatial domain catalogs that then can interoperate with their data. So if you already have those workflows, maybe you can pull in data quite easily. And we're building basically on top of some of our data catalogs like Cubed, which shows you the exact data there, some high-level interfaces, which I think could be quite nice and really helpful for maybe non-expert users. Okay, so just last slide to have some documentation. I've only showed the example of the plots here, let's say, but if you want to get down and dirty with the data, work with the code, there's lots of examples there, and you can scan that QR code. And also there's a training tomorrow with some more information. So yeah, thank you, and I'll hand it over back to... Yeah.
Thank you, Adam. Round of applause, please. So I can save you time and effort on the Belgian time series. It's just grey and boring most of the time. There's an odd spike every now and again, but you can verify. But lived experience, it's grey and bland. So now we're going to move on, first with Claire Bion from Gael. So please, Claire, come and give us your access the capabilities of Destined Earth presentation.
Thank you. Hello, so my name is Claire Bion, and I'm working at Gael System. So I will present you the Prismera tool, which is a visualization that allows to access the storyline, the Climate Digital Twin storyline dataset. This tool has been developed in collaboration with ECMWF and ESA. And it's currently available on the Destiny web portal under the Climate DT second generation section. As it was previously described, the storyline dataset allows to replay an extreme weather event under different climate conditions. So the tool is here to facilitate the exploration of this dataset and to provide the tools for the end user to visualize them in an easy and interactive way. So in this way, three climate conditions are taken into consideration. You have the past area that correspond to the pre-industrial times, roughly around 1950. You have the present day that represents the current climate condition today, and the future, which is a projection of a global warming of 2 degrees. So what the tools allow to compare side by side the replay of the event. You have a timeline that allow you to navigate through the event time. So this times, what you see on the board is the event occur on July, and you can navigate through the event. For the first release, we focus on 2 extreme weather events that happens recently. So that was presently also presented. So it was the heat wave in Western Europa in 2019, and the flood that occurred in Central Europa in 2024. So now I will present you the main tool of the application. So you have the event tour. So we developed these tools to provide the user an historical context of what happened and how the event was when it happened. And these tools allow navigate through the application to show you what is interesting to observe. Then you have the map visualization, so you have side-by-side maps. You can pan, zoom, and scroll the timeline. As it is sometimes difficult to observe the small differences between 2 scenarios, we have developed a comparative tool so that it highlights the small differences between the 2 scenarios. If you want to analyze a specific regions, we provide in the tool the NUTS administrative regions. So you can select one region, and the tool automatically display time series, and you can that correspond exactly to the selected regions. You have also the possibility to select a specific point or to draw by hand your polygon of interest. As it is not always easy to interpret data plotted on a map, Prismera provides also key insight indicators. So these indicators translate the data into concepts that people already know in the current life, like the heat wave exposure. So the heat wave corresponds to a period when the temperature is above a certain threshold during a period of time. This value depends on country, so the tool lets you choose your parameters, and then when you click apply, you have all the cities that will be affected by the heat wave according to your parameters. Another index is the heat index exceedance. So it characterizes the tropical night when the temperature doesn't decrease enough significantly to allow the human body to recover from the heat of the day. So in the same way, you can select your parameters, the temperature threshold, and the duration of the night, and it highlights all the cities that will be affected by the heat wave, and the color indicates how many tropical nights will happen. So we think it can be a good tool to point out where the population could be at risk. And then the final tool is to share your view. So imagine you have configured the application and to focus on a specific area. You can, Prismera allow you to generate a link, and you can send this link to your colleague so that he can reopen the application in exactly the same state that you have observed. And this concludes my presentation. Don't hesitate to contact us if you have any further questions.
Wonderful. Thank you very much, Claire. So, I invite you to take your seat again. Thank you very much for that. Ignacy, clock ticks, and the floor is yours, please.
Thank you. So, well, I'm going to present you the Open Viewer that will be implemented in the Destination Earth platform very soon. So, basically, probably, as most of you know, climate models until now had a kind of coarse resolution of 25 kilometers scale or a daily time step. So, with that resolution, they are not really capable to resolve some of the climate phenomena that are behind of some of the climate extremes, which might be extreme precipitation rainfall or even extreme heat waves. But now, with these three new set of models of 4-kilometer scale and hourly resolution, we have the possibility to explore how this climate phenomena will evolve in the next warming planet. So the Open Viewer, but here the problem is that it is data, of course, it's a huge amount of gigabytes, of terabytes, that standard users don't have the enough computational resources, or maybe don't have the expertise to explore the fullest of these models. So the Open Viewer is where it comes. Here, the Open Viewer will be a window to that model where the user will have the ability, the capability, not only to explore how this data will look like, also to interrogate that data and interact with that data in a creative way. So this Open Viewer will have four main sections. The first section will be a climatology section. The climatology section will be a kind of global map where some relevant climate indices will be displayed based on precipitation, temperature, and so on. For example, hourly accumulated precipitation, maximum hourly accumulated precipitation, 3-hourly accumulated precipitation, or daily maximum or minimum temperature. Even more, the user will have the ability to go at one point on that global map and see the monthly time series of these relevant climate indices, but also in a country level or in administrative level, European level. The next section will be a climate stories section. We will show examples of climate stories that only this type of climate data are able to tell us. For example, extreme Mediterranean rainfall or urban heat islands. In the case of extreme rainfall in the Western Mediterranean, we will include the data that are involved of that climate story. For example, a warming sea surface temperature is responsible of more vapor in the atmosphere that fuels those type of storms. So here the user will have, in an interactive way, will know how these variables that are responsible of these climate stories will evolve in the next decades using these models. Another section will be where the user will have the ability to interrogate the capability to interrogate this data, asking for its own climate indices that are not in the climatology section. For example, some people might be interested on 6-hour precipitation, accumulation of 6-hour precipitation, or even how many days maximum temperature will not go below 35 degrees, how many days per month. So this type of climate indices will be open to explore for the users in a very intuitive way, following a menu and selecting the region of the user that is interested with. And the last one that is we are still working in trying to develop is we will implement an LLM interface where the user will not only to ask for new climate indices that is interested with, but also will be able to create its own data viewer based on the specific question that the user wants to answer. So basically, the outcome of that Open Viewer is to make a kilometer scale this climate service the data accessible, explainable, and meaningful in a very creative way to not only for the scientists, but also for the general public that don't have the capability to explore at the fullest this type of data. So here is a a little demonstration of how the data viewer will look like. And as you can see, we can see with really detail some of the features of Europe, in that case in the Alp region, but also in precipitation terms and so on. So thank you very much. If you want to know more about that, you can reach me in the demo section after that, at the end of the day. And yeah, any feedback will be very welcome as well. So thank you.
Fantastic. Thank you very much, Ignacy. Take a well-deserved seat. Without any further delay, we pass now to Daniele to make the final presentation.
Okay, so good afternoon, everyone. Today, I will present to you some services which can make you accessing Destiny capabilities. So I will focus my presentation on the services provided by the data lake, which is one of the components of Destinationers ecosystem. So those services, there are 5 today. There is a harmonized data access one, providing access to a wide catalog of data, leveraging the distributed infrastructure of Destinationers data lake. It has been briefly explained before, but Destinationers new climate DT data as well as extreme DT data are produced on the HPC centers. To host those data output, some infrastructure has been installed in proximity to those HPC centers, HPC Lumi, Mare Nostrum, and Leonardo, in order to host the output. An additional infrastructures has also been added close to big data stores in other locations. So using these distributed capabilities enable user to access the data in an efficient way, in proximity, and then providing processing capabilities there, so meaning you can spawn your processing in those different sites, able to create new applications, leveraging those new data produced within Destiny, together with the other operational products available within Europe. So the harmonized data access provides access to Destiny digital twin data together with a wide data portfolio. I will describe it very high level just after. And the edge services enabling development of new applications, supporting decision making, to adapt to climate change, etc. Or the following: stack, islet, hook, and storage. Those are on request, and thus each Destiny user which want to benefit of those to build a new project, for example, need to submit a project request, and then this project request is assessed by the teams and approved by the commission. All of this is possible through My Data Lake Services tool accessible through Destiny. This is I have not mentioned, but this is a cloud-native platform. All the sites are connected together. So let's begin the Destiny user journey. If they want to access those services, they start from the Destiny platform. They have a Destinationers account. If they want to benefit from the climate DT, extreme DT data, for example, they need to get an upgraded access. They go to discover the services in order to access the data lake once to enable new developments near the data, on the edge of the data. They have to select edge services, filter. Here it's an example using HDA1, and then they access the service. So here, an example of while a user is entering into the Destiny HDA service, he accesses a UI where there is a wide catalog of data sets. Here I took an example of one data set, which is one data of the generation 2 newly produced by ECMWF. So each data set is categorized by a collection, and here the filter is applied to Destiny data, but consider it's organized and accessible to the community in a seamless way for other providers. For example, for European statistical data set from Eurostat, from some product produced by GRC, for some EUMETSAT operational data, other data from ESA mission, etc. So all of this, the idea is to have it in a unified way. So it looks like that. If you enter in the climate DT page, you can have further information, which then points user to the platform for further information about it. For each collection, each data set available behind the Harmonized Data Access Service, the information are organized seamlessly for user to enable data fusion, combination of data to develop new applications. So here I took the same example, one of the collection of climate DT. You can see how the information are organized. Consider it's the same for any kind of data from the catalog. You have a title, some keywords enabling a search, description about the data, eventually the model used, if relevant for this specific data sets, the temporal extent, the list of variables, which is, in this case, extensive. You only have a subset. But it is how it looks like. So this is what HDA provides to the user. In this case, it's a graphical user interface through data.destinationers.eu. It's graphically, but this graphic user interface is based on HDA API, which enable user to programmatically access the catalog, discover it, and the access of this data catalog is then subject to the data policy of the different providers connected to HDA. So the catalog and the API is based on Stack standard, which is a widely adopted standard in Earth observation community. And all the metadata are organized the same way. So this is more information about Stack standards, but will not describe further since it's quite well known and many information are available online. Also, we have a booth to describe this. So if you want to look at how it looks programmatically, this is how it looks like. The information are the same. In fact, it just, you can call it with your program, your script, whatever. So to sum up, HDA offers through the Destiny platform access to the new destinationers data, together with other data from a wide catalog, with a unique credential, a unique API, so harmonized, and based on Stack standards. Today, there are more than 250 data sets connected to more than 15 providers, and the idea is to have a complete data portfolio. So the feedback of Destiny user here, it's very important and relevant to make this portfolio extended to match many use cases. In addition, within Destiny ecosystem, user can produce new data. And thus, those data can then be stored on the data lake, on Destiny, and then be exposed later on following an approval process, quality assessment, etc., to the community to create on top, if needed, new application, etc. So that's the main concept of how to access Destiny data portfolio through HDA in this case. And this is open to any user. The near data processing capabilities are a complement to this service in order to make data, to ease data fusion in proximity, as I said in my introduction, to the location of where the Destiny infrastructure is built. So there are different kind of level of services for different expertise, for different kind of user. For example, ILET is more an infrastructure as a service. So let's imagine for developers who want to build an application and manage their own resources. So they are granted a certain pool of resources based on a pod stack. They can instantiate Kubernetes cluster, only request storage. It's quite on demand, and then build their application. Hook, which is more user workflow focus, or Stack for scientists who wants to discover the data, visualize the data, for example, or they can also do distributed computing using Dask framework. All of those services are under request, I just said it before, and it can be done using my data lake services. This is the infrastructure of data lake, where all the services I explained before can be spawned in proximity to the data, Destiny data, but also to other big data stores. To complement this offer, we are working on new also AI/ML tools, which will complement the portfolio of services. I will not describe them now because we have dedicated morning on AI activities tomorrow. But in short, there is an MLOps platform in development to ease the development of application using AI. DFAIR, which is a destination nurse framework for preparing AI-ready data. DEDL Cube, DEDL aka Destination Earth Data Lake, to structure access to multidimensional Earth observation data. And last but not least, and this one is actually operational like the first services I introduced you, the Edge1 and HDA. It's a widget, a chatbot, an assistant which helps to guide the Destiny users through the documentation. For example, for user who wants to deploy their services or their application using ILET service, which can be quite complex for scientists, they can use this chatbot, which is quite helpful to ease this kind of deployment, for example. Here some statistics on the project. So as I say, to deploy some application, do some work on those distributed infra, user needs to submit a project. This is some statistic of the current status of how many projects we have, what kind of user. So you can see there are many applications on development, 41 today, covering different areas and different kind of users. So I think it represents well Destiny community. And this is my last slide. I will conclude with some information for the future. If you look offline and pointing to the demo station of Destination Earth Data Lake. Thank you very much.
Thank you very much, Danielle. So there we go. We've had some quick snapshots about alternative access pathways into the platform and the data lake, back-end enabling services and tools like Polytope, new platform visualization services such as Prismera and OpenViewer, and the integration of data into decision support tools for public authorities. So that was a very rapid tour around some of the new capabilities and services that are now on offer. Now, we're going to have another 10-minute discussion, but before we do, I would like to invite Ignacy, Claire, and Adam to step down from the stage with our thanks for great presentations. And in their place, I would like to invite two very well-known figures from the Destination Earth ecosystem, Franke Kuntz, the Earth Science Model Engineer from European Space Agency, and Niels Veddy, Digital Technology Lead for Destination Earth at ECMWF. Frank and Niels, please join us in a quick round of applause for Claire, Ignacy, and Adam, please. So we have a narrow window of time to focus a little bit on the co-design workshop, which took place earlier today. And so, Niels, you're going to take the lead and give us a few quick headline messages of what took place, what the big breaking news was, and the key takeaways.
Okay, thank you.
It should come, yeah.
Yeah, thank you very much. So I think the key point, as you realize by now, is that translating scientific uncertainty into actionable insights is non-trivial. And it's precisely like the goal of this co-design workshop that we had to focus on that, to bring into one room AI developers, infrastructure owners, infrastructure developers, climate scientists, weather experts, application developers, impact sector experts into one room in order to lower substantially the threshold of creating actionable insights, to lower substantially the threshold of engaging with Destination Earth services, and basically problem solve in real time. So this is what we've done over the last 1.5 days. I think we had very positive feedback. I don't think it will be the last time we do this sort of thing. I think people were overall very appreciative over what they learned, how they were actually realizing, oh, this is how it actually worked, you know. Oh, I didn't realize. So I think we had these sort of aha effects from some of the participants, which is great. The other sort of important point really is it is non-trivial to do this translation. And we have this whole zoo, if you like, of just the presentations you've just seen earlier. But don't sort of be put off, basically, because it is actually not difficult. During the co-design workshop, we very clearly showed that we can address a broad range of users from a broad spectrum of users, be it general public type users that want to sort of compare with their own data that they have measured in their garden, to expert users, information brokers that can really inform policy. The tools are there. And one of the key feedbacks we got as well is that we should better guide, basically, users in using these tools, using machine learning, using AI. And I think one of the key aspects of the future phase 3 is to better connect the different applications, better guide users towards which service basically is best for them. And I think that will be a key outcome from the co-design workshop.
Okay, so let's give the mic now to Franca. Franca, any key takeaways from your side?
Yeah, thank you so much, Niels. Basically, you summed it up already. It was very successful, at least from our side. I actually didn't attend the co-design workshop because I was busy in another networking session to gather feedback from the users. But we are in close contact with all our colleagues to gather all the feedbacks, just to tell you that we're all working together to make everything happening, because we know Destiny is complex. We can see it. I mean, with all the presentations, you can see there's so many specific technical details we need to convert in something very useful. And the best way to do so, it's also what we figured out, to actually meet with the users and the technical people in person and to discuss with them in person. This is very, very important. And I think this was very successful. We're continuously doing this. We also have more networking events, more events where we actually connect to the users. For example, from ESA's side, we set up a stakeholder engagement team to fully work with specific users to adapt services to users' need, to listen to them, because we know that they have very, very useful feedback to be integrated. And Niels said it already, the need for services to be AI ready and all the descriptions which needs to be AI ready. And we are working on that also from platform side to make this happen. So I hope by end of the year we have something ready for you to use, all AI ready, so it makes easier for you. And then, as you said, that's important to connect all the services we already have. We have a huge ecosystem already. There are more coming, but we also need to make sure that they can interact. And this is also something we work on. This is a big focus on phase 3 to make all the services work together. And easier to use. And then one feedback I would like to add to your feedback was, this was, a lot of services we have in the platform is very specific to one location. And we know that. For example, the urban services we have, they are specific to Copenhagen or Bologna, and we know that because everything is complex. So there is really a need for these services to be scaled up to other locations. And this is something we would really like to focus on.
Fantastic. That's a pretty comprehensive set of takeaways. You said he'd already done it. You had plenty more to add, so thank you for that. Danielle, anything further from your side? I mean, from what you heard and absorbed from the user engagement this morning?
So a lot has been said already. But I will complement with my feedback. It was great to see end user of destinationers, but also with destinationers implementers. So from the platform services point of view, from a data lake point of view, also the person modeling the data, the destinationers that digital twin data, or to everyone together in the same room, because we could see how everything interconnect together. All services sometimes rely on each other or rely on data from the different entities, the different actors, and thus having everyone in the same room gave a big push, I think, to answer very easy questions sometimes. But you know, when everybody is in the same room, it's much easier, and to have the end user also in the same group, able to foster the co-design and give really a boost for future development of the services on destinationers. And I would like also to do a parallel with what you say, Franca, is a lot is already happening on destinationers, and I would like to have this also as a focus of phase 3 to really highlight the ongoing work of the different users on Edge services, because there are many projects ongoing, but it lacks some visibility, is lacking on what's going on there. So it's really, I think, a focus to to work on to make that visible, inspire the community, and create very useful and new services for Destiny ecosystem.
Okay,
Thanks.
fantastic. Well, it sounds as though you've come up with a very good idea. Formula maybe needs a little tweaking here or there, but very positive takeaways so far. And obviously you'll have a chance to interact later on during the event for more feedback and ideas about how to do this again, repeatedly, even better. But congratulations on a very successful start to the user exchange. So it's about time for us to begin our final panel, but please join me in thanking Nils, Franca, and Daniele again for their feedback on the workshop. And I invite you to leave the stage. Oh, I feel as though I've been sitting down a lot today. So let's get to the final block. We may still be missing one of our commission speakers, but we will proceed because we have a ticking clock and plenty to discuss. So the objective of the final session, as you probably intuited, is to get some high-level perspectives from policy on the what next, and in particular from the European Commission, not just to echo or to amplify what we've heard earlier about the demonstrated value of Destination Earth through phase 1 and 2, but to think about how its capabilities, its data, its tools, and its services can support something that Daniele was referencing a minute ago, how to connect all of, and Franca, how to connect all of these different services, how to be a driver for different parts of the policy-making world to progress towards their strategic goals with regard to climate preparedness and climate action. So for that, we have a rare, dare I say, extreme event in Brussels context, which is to have 5 Commission Directorate Generals represented in this closing discussion. Which again, if you've never been to a College of Commissioners meeting, that's about the largest number of commission people that you get together in one place at the same time. So this is really kind of a breakthrough. And so I hope you will join me in welcoming our policy colleagues to the stage for this discussion about how Destination Earth can be a driver towards policy goals and objectives in the years to come. And so we'll do this in alphabetical order. There's no hierarchy within the Commission, as we know. So first, Elena Bardrem, who's the Director for Climate Resilience and Information Management at DG Klima. Elena, please just choose your seat. Thank you for being with us. Next, we have Christoph Kautz, Director for Space Policy, Satellite Navigation and Earth Observation at DG DEFIS. Third, Ariane Labat, Head of Unit for Digital Transformation at DG INPA. Welcome, Ariane. Michaela Matuella. Has Michaela arrived yet? You're here. Fantastic. Michaela's the Director for Emergency Response Coordination Center at DG ECHO. And last but by no means least, a very familiar face to us all, Rosina Piesiewicz, High Performance Computing and Applications Head of Unit at DG Connect. And I think we get to call you the godmother of Destination Earth, given just to close the loop on that. But we're going to kick things off with actually a question for the audience, on site and online, which is the following. So hopefully if you've got your phones out, you can connect to Slido. We're curious to know, before we talk to actual policymakers about how they are going to use Destination Earth in future, based on everything you've heard today, what are the areas of policy making, whether that's EU or national, that you think would benefit most from Destiny moving forward? Okay, so we're going to give you a minute to enter your top words, your buzzwords, your big ideas. And we will give it 30 seconds. You can do it as well, by the way. I don't know if you brought your devices up here. We don't want to preempt your discussions and your answers, but if you feel like contributing to the survey, you should feel free. Okay, so we can ask the AV team to give us a first quick glimpse of the answers and see whether we can get these in some kind of word cloud or chart or poll, which hopefully they can do right now. if possible. Okay, so who might benefit from Destiny services and capabilities? Okay, national, subnational institutions, scientific users second, commercial services about the same, and European institutions in fourth place. Right. Let's change that dynamic by talking about how the European institutions are going to derive enormous value from Destiny moving forward. Okay, so thank you very much for your answers on that. Grzina, how about you kick us off with challenging what the public thinks? But I guess, given that you've been involved in this journey since the very beginning, I mean, how do you think, in response to what's gone into that poll, how do you think Destiny can best support member states in their future efforts to respond and adapt to climate change, also based on what the platform can realistically deliver today? And I guess in parallel, what role do you also think it can play in deepening the AI capabilities across Europe?
Is it the member states you asked about? Or?
Yeah.
Okay.
Member states.
Right, that's a very complex question, quite a few elements to that, but I would like to first comment on being the godmother of Destination Earth. I really don't think so. I might, at best, have been the midwife, helping it,
Very nice analogy.
be born in as quickly and as painlessly as possible. So maybe that would be more of a role. I think, again, we're here again, at again another juncture, and starting phase 3, the final phase of what has been an incredible journey at the beginning, when many even doubted that the vision and the ambition that we had would ever be translated into something concrete. So, we are defying all the, what's the word in English? The skeptics, I would say, and almost every year, we demonstrate that, when you collaborate at that level and when you bring the tremendous excellence that we have in all across Europe, it can give something very, very powerful. So now, of course, we have converted some of the initial skeptics, including, in our nearest institutions, that not only it is possible to deliver what we set out to deliver, but that it is actually sort of responding to some of the needs, but that may not have actually been realized, by the users that they may have, and that they may actually satisfy those needs with the capabilities that Destination Earth offers. And I think, we try to be good and sort of very thorough in what types of uses we imagine that we could put to, and we go almost like these salespeople knocking on people's doors and saying, look guys, we have this wonderful product, please have a look at it, and try it out, and more and more as we get better at selling what we have, people are sort of looking at it more and more favorably. So I think first of all, we have developed the really breakthrough, and I do not take any credit for this, obviously, because that credit lies with our amazing interested entities and the whole, all the institutions behind it. So really, we rest on the shoulders of many, many people. But I think we bring these capabilities at a time that, stars have to align in a sense. So we bring these innovative capabilities at a time when the need is very, very pronounced, with the necessity to enhance our preparedness capacities and our resilience. And of course, climate change is a big challenge that we need to prepare for. And that, I think, is the alignment, in a sense, of stars that we are bringing. So there are many, many needs in this area that we can respond to by not alone, because that is not what's going to happen. We need to work hand in hand obviously with everything in this in this landscape that exists. So first of all, the many capabilities that our colleagues in Copernicus have already brought onto that stage and have been bringing for many, many years. So we have to work together, but there is, there is innovation that we bring from Destination Earth into enhancing those preparedness capacities at member state level, at local level, at EU level. There are many, and we can respond to some, and I think that is the main, really objective and challenge as well. But we're getting there. So phase 3 will of course still pursue the development of Destination Earth, but as was said many times today, since the very beginning, enhancing uptake, taking up the different capabilities in the very beyond use cases. We need to move, we are moving now, and we have already been moving in phase 2 from use cases to more concrete pilots, to services, making it sustainable, not demonstrating what you can possibly only do, but really doing it, and making it in a sustained way. That is really going to be the focus, an intense focus of phase 3 and beyond. So that's my initial reflection.
Very good. Thank you for that. Now, let's move the conversation on. I'm going to turn next to Elina from DG Klima. It should just already be on, Elina, so it'll come to you in just a moment.
Okay,
They'll switch on for you. So this question about how other services can leverage what Destination Earth has developed. I mean, for DG Klima and also your work with the European Environment Agency, we've got some pretty important climate preparedness files coming through the system, including the Integrated Framework for Climate Resilience and the next Climate Risk Assessment. So how do you think that these services, these tools, can help you and your colleagues in those kinds of files?
Thanks for that question, and happy to be here. And I'd like to start by congratulating Connect for all the progress made. When I first heard of Destin-E and saw some simulations, I must say that I was one of those skeptics. I thought, this is science fiction. It's just way too advanced. But the progress made and the cooperation that we have had has been really a very powerful example of how we can bring science closer, science and evidence closer to the policy making. Let me start very briefly by just stating 2 facts that drive our work in DG Klima in building climate resilience and readiness, which is of course part of the broader preparedness agenda of the Commission. Fact number 1 is that scientists are increasingly converging on 1.5 degrees threshold, the lower threshold Paris Agreement, being surpassed more permanently in the coming years. Now, of course, we want to make extra effort and double down so that that overshoot can be limited to as much as possible. But in the meantime, we really do need to prepare for a drastically different climatic reality in which we need to prosper, do business, compete, and bring up our children. So that's fact number 1. Fact number 2 is that when we carried out the first European climate risk assessment, it showed beyond any doubt that our policies and measures at the union level, at member states level, are not keeping pace with climate change. So unless we get away from retrospective policy making to anticipatory policy making, we're going to be playing catch up and we'll never get ahead of the impacts. And this is where I think that the kind of visualization and understanding of the consequences is absolutely imperative. So the framework that we're working on is something that will establish a principle of climate resilience by design, which again is part of the broader preparedness by design. But in order for us to allow policymakers and public administrators to kind of substantiate what this means for them and how do they implement their respective duty to consider that new climate reality, we need to provide them with tools. We need to equip them with a decision-relevant information that allows them to make more informed, anticipatory decisions. And the different models that have been constructed, the storylines and the sectoral impact models are powerful tools for making the impacts more concrete and relating that to the decision makers at all different levels. And I saw, national, subnational institutions, and indeed, it's very often the local authorities that are in the front line of climate impacts. They may not have so much time to get their heads around complicated data sources, etc. So ensuring that the solutions are tailor-made and relatable is going to be of high relevance. So we'll continue to work with our colleagues in Connect and the other services to make sure that when we are producing and developing tools that allow people to implement the climate resilience and risk management framework, that they are equipped and empowered to do that in a way that takes into consideration the probable realities and allows them to really visualize in very concrete terms what this means for their particular context. And I liked what someone was saying in the earlier panel. This information is location specific. So if we say that EU is warming twice the global average, we pass 1.5, so on average 3 degrees for Europe, it's not going to be the same 3 degrees in Greece as it is in Sweden, or in Poland as it would be in southern France. So we do need to really become quite granular and have these high impact solutions, high resolution models that allow us to be very context specific. So we have great expectations. We're really encouraged by the work that has taken place so far. And I think when we provide with the framework, we really do need to provide those tools and possibilities as well. Thanks.
Fantastic. Thank you very much, Alina. And I love this framing of anticipatory policymaking, because, of course, in President von der Leyen's first mandate, foresight was introduced into the college for the first time, but foresight done by people. And now we have these incredibly powerful tools at our disposal that can do it at a scale beyond our human comprehension, and hopefully ones that can really support strategic policymaking in the years to come. Now, speaking of strategic tools and big pictures, I think it's time to turn to Christoph, because, I mean, in Grzina's opening remarks, she also mentioned the importance of trying to leverage what Destiny has been developing with what's already there. And Copernicus is one of the great examples of, high-tech Earth observation, satellite space, technology, collaboration. So my question to you is, how do you think, or in which ways could a closer integration of the emerging capabilities of Destiny work with the Copernicus ecosystem, and in particular the services and data spaces that you have already established? And then maybe we'll have a little follow-up question about what the lessons from Copernicus could benefit phase 3 and next steps for Destiny. But let's start with the integration first.
Okay, thank you very much. Just to say that, of course, we have been thinking and working with our colleagues from DG Connect since a while on how could we foster closer integration, particularly in the next MFF, and we have intensified this work in these contexts in the last months. So I think, and you hinted to it, there's the obvious element of data. So of course, Copernicus provides a lot of data, and these data, they can usefully feed, of course, into Destiny. And so I think an obvious element would be perhaps a closer link of the Destiny's digital platforms with the Copernicus distributed data nodes. At the same time, of course, data also in terms of AI can refine the raw Earth observation data provided by Copernicus, and therefore providing more precise, or allowing Destiny to have more precise models. So I think data clearly is an obvious one, and then services. And on services, I think it goes both ways. I mean, there's elements where Destiny certainly can complement Copernicus services. So when it comes to, kilometer scale resolution or hyper-local zooming in, things that we cannot do with Copernicus. And then, of course, Destiny's what-if scenarios, they can feed into the Copernicus operational services and improve our services. So, as I said, it goes vice versa. Then we have also a technical dimension, I think, where we can better integrate. So, Destiny does these ensemble simulations which can support the validation and calibration of Copernicus products. At the same time, and this goes perhaps a little bit beyond Destination Earth, is DG Connect, of course, is working a lot or has access to Euro HPCs and AI factory infrastructures, and we think that this input can help us also to accelerate, if you want, the Copernicus numerical transformation, or however you want to call it. And then on the user side, it's perhaps the later element of your second question. I think Copernicus has hundreds of thousands of users, and I think this user base can be leveraged also for Destination Earth. And also the user feedback that comes from Copernicus can perhaps help Destination Earth to avoid some of the errors we have made in the past. Yeah. So I think I will leave it here, but you see there are many things where we can work on a better integration of Copernicus with Destination Earth and vice versa.
Thank you very much, Christoph. It would be indeed a great shame if we don't manage to make these two success stories, albeit with slightly different time series and maturity levels, to work together in a very synergistic way. So thank you very much for those perspectives. Now, we are going to turn to Michaela next, and DG ECHO. And we had some very interesting sort of use case studies in the ECMWF, the Destiny event in October. And it seems as though, for all that we've heard around local applications and so on, the work that ECHO is doing is perhaps a very natural funnel for that, and dealing with emergency respondents at a local level, right? So on the ground. And so the question that we had for you is how these services, platforms, and tools, how can they actually enhance the preparedness and response efforts that you are trying to coordinate within ECHO? And then in parallel, because we've talked a lot about the AI revolution and the AI capabilities being linked to Destiny, how those can help to transform this sort of real-world, real-time impact for managing risks in local communities and on the ground.
Well, first of all, thank you very much for having me here. I'm very happy to join this debate and this panel made of colleagues with whom we have, of course, a lot of interactions. And if you allow me to make maybe first a precision in maybe the angle that I will take in answer your question is that being the director of the RCC, so the Emergency Response Coordination Center, let's say the role of the RCC goes also a little bit beyond, let's say, the specific mandate of DG ECHO, which of course focuses on civil protection and humanitarian aid. And this is also the result of the reflections that we had in the Commission, which led us to issue the Preparing Union strategy last year. And in that Preparing Union strategy, there is a proposal that is currently a discussion with member states. I will not go too much into the details of that, but it's important contextual elements. In that proposal, we have suggested that we develop a EU crisis coordination hub building on the Emergency Response Coordination Center, which means that we want to go beyond, let's say, the civil protection, the humanitarian angle, to basically increase our capacity to make the connection with the different policies in the Commission and be more effective in our preparedness. And that's a very important shift in our policy, if you want, and this is, let's say, one dimension of it. So putting aside, let's say, this context, I'm very happy to come in after the colleagues that have taken the angle also of the policy developments in their sectorial field of expertise to bring the dimension of, which is more operational, because that's our role. Our role, of course, is much more operational, and how do we use all let's say, the source of information to be better equipped for response and preparedness. And thank you very much for bringing the two dimensions, because certainly one of the objectives of the Prepared Union strategy was also to basically make the point, and let me go for an oversimplification, of saying, of course, we need to, of course, maintain the focus on response, but we cannot deal with response only. The challenges are too big. They are increasing in quantities, quality, diversity, and therefore we need to focus and invest equally also on response. So from the point of view of how do we use all this, I mean, first of all, let me make the point that we already benefit very much from Destiny, because this is really feeding into our day-to-day situational awareness capacities. We already make use of it to strengthen our monitoring capacity, our forecasting capacities for the heat waves in Europe, for the floods across the world. So this is already a reality. And all these feed into our analytical products that we use to guide better our response. Take the example of daily maps. We produce daily maps together with, of course, the colleagues from JRC, and these are concrete instruments that we use to guide our response. What we need to look at now in terms of how else, how further do we benefit from it, clearly we need to go into the preparedness angle more. So we need to, for instance, look at how we can better use the climate DT, the digital twin, which of course will be very relevant from the better anticipation, better preparedness. I take a very concrete examples as well from our operational perspective. Every year we deal in Europe with what we now call the wildfire season. The wildfire season is basically, as you know very well, a big challenge in many countries in Europe. This wildfire season is becoming more complex, it's becoming longer, it starts earlier, it finishes later. But also the wildfire behavior has changed drastically. And the more we manage to anticipate, better understand the risk, better understand these behaviors, better we are prepared to anticipate, of course also to respond better, but most important to anticipate, because the anticipation is what certainly will help us limit the damages. So this is certainly in terms of, let's say, the further development of the use of Destiny is concerned. You made a reference to the artificial intelligence. I must say this is very much a topical issue for us in our community, the civil protection community, now I refer to that, which is a civil protection community that of course has also a humanitarian mandate, and I'll come back to that. We had, just to take an example, we had just in April a meeting of all the Director Generals of Civil Protection of the Member States. Artificial intelligence, the use of artificial intelligence for preparedness and response was very much on top of our agenda. Last month we had the meeting of the Early Warning System Experts Group, again with all Member States. This again was on the agenda. So there is a lot of discussion also in the community, because let me remind, of course, that the Commission in this field has supporting capacity, so the main responsibility for emergency remains with the Member States. And the artificial intelligence, I think that in this community, I don't have to explain it with many words. The complexity of reality, but the complexity also source of information is gigantic. But we need to find a way to translate all this information that is there into an actionable knowledge, because otherwise this will not help us in dealing with preparedness and response. And without artificial intelligence, it's simply not possible. We will not be able to process all this very valuable information. It's as simple as that. And there's a lot of work going on for that. There are, of course, the challenges of that, but there is certainly a great potential that we are developing together with the Member States. Thanks.
Okay, thank you, Michaela. That's fantastic. I mean, I'm delighted that you say that, because you came only a few minutes before the session, but actionable intelligence, actionable information has been a red thread throughout the event, so you've hit the nail on the head there. Okay, now, Ariane, you've been waiting very patiently, and I think it might be fair to say that the DG INPA, International Partnerships, is perhaps fairly new to the Destination Earth ecosystem, but We've also been talking earlier about the possibility of using these kinds of tools and platforms for Europe's leadership in the world. And this, of course, lands very squarely in the remit of INPA. And so the question that we had for you is whether you see any particular ways in which the platform, its tools and capabilities, can actually strengthen the programs and investments that INPA is making through the Global Gateway, for example. We could think of the green and digitally enabled transition in Africa, and whether there are any sort of structural or systemic gaps that its capabilities could help when we're looking to strike global partnerships or build these partnerships of trust and mutual benefit with other parts of the world.
Thank you, Simon. Thank you, distinguished colleagues, for having me here. Just to locate us, indeed, in the European Commission. So our day and night job, as I must say, is really with Global Gateway strategy to unlock, to de-risk, to facilitate investment in the mutual interests of our partner countries in Sub-Saharan Africa, Latin America, Caribbean, Asia Pacific, and in our EU interests of security, competitiveness, climate action. We are really geared by that investment agenda. So I just want to place out what we do. And Destiny definitely is a key component of that. So in 3 ways. Number 1, it's a very fundamental building block of what we call the EU tech offer to our international partners. We have said that very clearly in the EU International Digital Strategy. We are a reliable, trustworthy partners for anyone around the world who want to build a human-centric digital transformation. And Destination Earth shows a real case example. You're federating Copernicus excellence from DEFIS, whatever is happening in Connect, and you put it out to the world, and our partners are highly interested in that. They recognize the excellence of all these different EU programs coming together, and they have a very high demand for it. And on our side, on INPA side, we also bring in financial investment into the system to make Destiny closer to the users. So 2 examples, under the Africa-Europe Space Partnership, we have 20 million going into strengthening early warning system in Africa that directly build capabilities and bring forecast in a box closer to our partner countries, whatever their level of capabilities. Second example, in Southeast Asia with Philippine Copfield Center, we do the same. We bring closer to the user in our partner countries the excellent program from DG DEFIS. And this does matter because it's a door opener for us, together with colleagues from Connect, from DEFIS, to discuss with our partner countries of all the other layers, all the other excellent pieces of the EU tech offer, because we have excellence in multiple segments, in secure connectivity, et cetera, and that's an entry point, if you like, of our conversation on developing such investment with EU businesses. Second way, exactly as my colleague from ECHO explained, and also Elina on the climate side, the contribution we bring to strengthening local capabilities of our partners to have functioning early warning system is tremendous. This has direct value. This is a digital public good ultimately, and once again, it matters for our partner. We are in discussion right now with colleagues from Connect and our colleagues in the Caribbean to develop the Stormwatch initiative. This will save life, okay? So this is very, very important for our partners. Number 3, I think more in a more forward-looking way, together with our partners, we are also exploring, the next wave of investments in all the global gateway sectors, transport, energy, digital, etc. And we need to do it in a climate smart manner, informed by the latest information. And we are already actively using whatever is being produced under Destination Earth to make this investment in where it can be climate resilient, where it can benefit our user the most. So these are really the 3 axes for which we are collaborating with everyone around the table. Thank you.
Thank you very much, Ariane. And there you go, in the space of 25 minutes, proof that synergies isn't just a buzzword in Brussels. Sometimes it does actually happen. So, Grzina, before we come to our final content inputs, our keynote from Martin van Elst, perhaps some final thoughts from you as the midwife, not the godmother, as I think we've decided. Yeah, we'll bet you a T-shirt or something similar. But look, we're now at this point where the negotiations for the next multi-annual financial framework are likely to get underway in earnest towards the end of the year. So, given everything that we've heard, I know this is preaching to the choir, but what do you think are the prospects and the priorities for securing Destiny's long-term future under the next MFF? And are there any particularly compelling arguments that either need to be reinforced or that we haven't yet really discussed that would sell its value as part of the next multi-year budget?
Yes, of course. I mean, today, perhaps it would have been more comfortable to be sitting here, in 6 months when we know a little bit more, because of course the level of uncertainty when it comes to everyone, while the Council and the European Parliament are discussing is always, there is a bit of kind of thrill, in the European institutions when that happens, and I think that level of uncertainty is heightened this time by the geopolitical situation that we know. So of course there will be some decisions that will be taken, but given my reference to the role of Destination Earth and potential of Destination Earth that has already been demonstrated, and not only as a hypothetical, as a potential idea, that is very far on the horizon, but that really an already demonstrated and tried capability, that responds to a lot of the preparedness considerations that we have. I think, from that perspective, I remain very confident that this is one of those elements that will receive, and it's not a question of receiving support, but my confidence goes to the fact that, or goes to the level that should be commensurate with our ambitions for Destination Earth. So, because you can have different levels of ambitions, and of course ours are high, but I think we are in a very good place to secure those ambitions, or to secure the means to realize those ambitions. And then, of course, I think the fact of having already tried and tested the capabilities of Destination Earth, also in almost daily operations. You heard that the national Met offices run and use some of our digital twin products almost on a daily basis. We have made our proof in the field, so to speak. I think the support from the side of member states, it is not only the Commission to say, pay for my nice toys, that I would like to develop further. It's really, it is a very concrete capability that has been tried and tested and brings concrete benefit to the member states. So my confidence also goes in that direction, that we will receive the support from the side of the member states, who then decide, are among the legislators and among those taking the decision on the final budget, to carry on with this project to the level that, to the level of the ambition that we have come to expect from it, and that we have imagined for it, I would say.
Perfect.
Let's see if I am over-optimistic.
Well, we certainly hope not, and who knows, I mean, this is just a personal reflection, given that my daughter just turned 13, but I hope if we have similar discussions in the months to come, we have DG EAC on the stage. Because I think the education and learning capabilities, or the potential connected to what has been developed under Destination Earth, particularly for kids to understand in a digestible, visually accessible way how our planet is changing and what their future might hold, I think that has huge power. But maybe that's for a separate set of conversations. So please join me in thanking our guests from the Commission who've given up their valuable time to be with us this afternoon. Regina, Elena, Ariane, Christophe, and Alina. Thank you, and Michaela, sorry. Thank you so much. I'll invite you to step off the stage, because we now have our final content piece, a last inspiring vision about the role, or the potential role, of Destiny in Europe's climate preparedness for the years to come. And for that, it's a pleasure to welcome Maarten van Aalst, Director General at the Royal Dutch Meteorological Institute, for a closing keynote and some inspirational words to round off the day. Maarten, goedenavond. Thank you for being here. The floor is yours.
Thank you very much. Wish I could say I was standing between you and drinks, but I'm standing between you and the group picture. I'll try to keep it manageable, but this was so inspirational. So thank you. I mean, I think if Destiny is already managing to bring these pieces together, that is already an accomplishment on its own. And I think we are realizing those synergies. And what I will do in my talk is give you a few examples of how these different elements of the potential of Destiny are actually visible to us in practice, and also where the needs are so visible to us in practice. Well, the start of the previous panel already spoke about the European ambitions of bringing the short-term emergency preparedness into the realm of the challenges in adaptation to what we have thought of as the long-term climate challenges coming our way. And that is, in fact, the daily reality that we are facing as national meteorological services. And we are in desperate need of the sort of tools that we've been building together in Europe as a European project. That we could also, and let me emphasize that as well, it's not a lot in my presentation, but I had expected to hear more of it in the conversation, so let me emphasize it now. That we can only do together in a world where having these types of tools, being the best in the world with this type of information, is no longer a given. When I started in this job 3.5 years ago, we had our ECMWF IFS, the best weather model in the world that I thought I could count on. We would comfortably just to keep improving those models, and we would be providing European citizens, European businesses, European governments with the best weather and also climate information in the world. A month into my job, I got a call from Florence Rabier, Florian's predecessor, taking note that the Google and Huawei AI models were getting scarily close to the performance of our numerical models. And within a few months, we have geared up to work together also on this AI challenge. And Destiny has been absolutely instrumental in keeping Europe at the forefront. And it is something I'm discussing partly with the sort of civil protection examples I'll be giving you now, but also with our Ministry of Economic Affairs on our economic competitiveness, and with our Ministry of Defense in terms of European strategic autonomy. So I don't think we can underestimate the importance of what Destiny has already brought to Europe, but also to us in the Netherlands, and my duties, ensuring that the Netherlands has the best information, but also keeps having the access to the best information in a strategically autonomous way. And that's not a given. That was not in my presentation, so I'll try and speed up on the rest. This is my predecessor 172 years ago, who actually started off. It's very interesting, the UK Met Office and the Netherlands Met Office were founded in the same year. And it was around the time, actually anyone want to take a guess why around that time, about 170 years ago, those two were founded? Any guess? Merchant ships were certainly one of the reasons why these two countries were particularly interested in having a Met service. But it became possible thanks to technology. It was the invention of the telegraph, just briefly before that, that allowed people to transfer data from one place to the other and bring them together to turn them into actionable intelligence. Indeed, for instance, storm forecasts on the North Sea, which we were particularly interested in. And interestingly, my predecessor was a professor of physics originally, but he wasn't doing very many super original things. And he felt like in this field of meteorology, I might be able to discover some new things. And the type of discovery he did was actually what we would now do in AI. He was looking for patterns. It wasn't a very physical approach. It was actually bringing data together and seeing the patterns that we could get. Now, of course, by now, our main tools are still the observations, but also the numerical models that we've been building very successfully in close collaboration, because the first thing that he also started is already starting to collaborate with our neighboring countries. Because it's one thing to combine with the modern technology of the telegraph, the observation from the north and the south of the Netherlands, but of course he figured out very quickly if we would start to exchange observations, for instance with the UK and for instance with Germany, we would get much better and also earlier forecasts, the game we still play. Now that game, I already mentioned the technological change we're right in the middle of, but it's also the climate change we're right in the middle of. And this was the moment, and of course, as scientists, I was part of the last IPCC cycle. I don't think anyone really believed we were going to hold the line on 1.5 at that point already. But this was last fall when Antonio Guterres also basically admitted our collective defeat. And he admitted that defeat indeed with the challenge to keep that defeat of crossing that line of the 1.5 bottom target of the Paris Agreement, to cross it as briefly as possible and with as little overshoot as possible. But he was also already challenging us to do even better on that job that we've been doing, in our case for these 172 years, transforming observations into data, data into understanding, and understanding into life-saving action. And that is our work every day. That has become even more urgent. And then in Europe, you're already referring to the Commission's imperative that will be formulated over the coming months and hopefully finished in the fall. This is a piece of advisory I was part of with the European Scientific Advisory Board on Climate Change, where we were trying to advise the Commission from the scientific perspective on what needed to be part of that. And again, it's that emphasis. There's elements of, you know, the social dimensions, which again we haven't talked much about, but there's questions of how we do this in a just way, where we take everyone along in each society, but also across Europe. There's elements about learning, about private adaptation, but there's very strongly also that anticipate and act component. And again, doing it at the shortest time scales, but also having the imagination of the unseen disasters that we may not have expected before, and where we now have new challenges for how we are prepared. This is the little segment from that five-piece thing. So anyone wants to know more, find me over the break or look up the document. And I was already mentioning, I've been in this job for about 3 years. This is in Dutch, but what you might see there on the right-hand side is actually a beautiful hand-written or hand-drawn weather chart from 1953, when we had our last biggest flood disaster in the Netherlands. After that, we spent tens of billions to protect our coast. This was 1953, the day before actually even just doing the calculations with paper and pencil and drawing these hand-drawn maps, they had seen that storm coming. Yet those warnings were not turned into effective action. In fact, they called our national radio station. We had one radio station the evening before the disaster and said, can you please keep up the radio station at night? Because it shut down at 11. And in Hilversum, where our broadcasting company is still based, our BBC sort of, they said, you know, those meteorologists, you always have, you know, you're so obsessed with your own field, it will be okay. We'll just shut off the radio station. And then at 2 at night, the dikes broke, and there was no way to reach people in those areas anymore. And we lost 2,000 lives. So this was serious then. The question I got, this was exactly 70 years ago on the first day I started my job. And the question was, could that happen, something like that happen again? And of course, we have invested those tens of billions. We have been surprised at times, by the way, by new types of disasters, like drought suddenly hurting us much worse than we had expected. We thought too much water was always the problem. But we've also had cases like this. Storm Ophelia in 2017, first hurricane to cross the Atlantic in our observational record. We know these things. We have Caribbean territory, so the storm watch actually affects my area of responsibility as well. But that's in the Caribbean where we're prepared for those hurricanes, not in Europe. Well, this was 2017. So we asked our climate scientists, was that something we should have seen coming? Well, this was our future weather simulation, not yet with the high resolution that we would have in the digital twin in Destination Earth. But at the time, we did have a climate run. But the first time we saw a hurricane crossing the Atlantic was in October 2098. So we are being superseded by reality in terms of our imagination of what could happen. And I think that calls for the sort of tools that we are building here in digital twins. And actually, we had here 2024, this was Kirk. This was one of those American plots we start monitoring in our weather room for the Caribbean use, where we are using the American products because that is what everyone in that region is using, and we want a single tone of voice. We hadn't anticipated using those for Europe. And of course, we're now doing the high resolution models to see what that means for the Netherlands, and the impact could be huge. So we have issued, just before Christmas, what we're calling an extreme report. Again, this is in Dutch, but it gives all the types of cases where we are now asking ourselves, what are those unseen disasters that we could imagine, the plausible things that could happen in the current climate, So we are no longer asking ourselves the question, what if we do not mitigate, and what might happen in 2100, and what is the cost of that, and therefore what is the business case for climate change mitigation? We are asking ourselves what could happen today. And I'm bringing that not just to the folks in the Ministry of Climate, where they want these storylines in their discussions with Parliament, but I'm bringing them to civil protection, and they're used for stress testing every day. And that is what we're using Destination Earth for as well. And again, it's very concrete. We had several people dying in sports events just the last month. The Dam tot Damloop, the famous one in Amsterdam, for those of you who are runners, we had an overflow in the emergency rooms, and they had to stop several sports events the past couple of years because they were worried they could no longer admit regular people with a heart attack, for instance. We've introduced something called heat intensity, more wet for those in the meteorology space. Well, essentially it's the combination of temperature, humidity, wind, and then maybe solar as well if you want, to give people an indication of how it feels for your body. And we need people to start getting it. And again, it's something we do together with health professionals, together with civil protection professionals. And these networks are emerging as we speak, because frankly, as meteorologists, 10 years ago, we had heat wave definitions that were only temperature. And I know that we did warn, but our forecasts were extremely ineffective in terms of actually preparing how we build our cities, but certainly also being acted on in sports events. That is changing, but it's coming still at a high price, and we're trying to make the best use of the small disasters we already get now in order to speed up the adaptation that is so desperately needed. But there's no longer adaptation for a little bit higher seawalls in 2100 if we expect a little bit of sea level rise. It's coping with the realities of today. And here's just an example of high-resolution heat maps that we're now using. I ran a simulation with the civil protection in the area of Amsterdam, where the mayors of Amsterdam and the surrounding cities were literally sitting around a couple of tables. And they were giving a scenario. It was Wednesday morning. It had been 34, 35 degrees, which is pretty hot already in the Netherlands, for a couple of days. There were little hiccups in electricity supply. One water supply location where they had some trouble with some bacteria, but it was all still under control. But now there was a forecast 60% chance of 40 degrees the coming weekend. And the Gay Pride is coming, so there's 800,000 people that are going to be on their way to Amsterdam the coming 2 days. So mayors, what are you going to do? And the first question they started debating on themselves is that actually my responsibility? Is that a city-level authority issue, or is it something that we need to deal with as a region, or is it something that the minister would be responsible? Actually, would other safety regions also be affected, and in that case, can we shift it to the national government? They started debating for the first 20 minutes about who actually needed to act. And then the second question was, okay, all these events in the Gay Pride, is it already in the permits we gave them that they need to cancel those events if it's dangerous because of heat? Because then it's their responsibility to start canceling the events, and how do we communicate that information? All of that, good questions, but questions that we could have thought about before, and where we would need to have the protocols. I'm very worried if I give a code red for heat with that 40 degrees coming, that it's going to take us the 2 days we still have left after the forecast to actually act on it. So my plea is, again, we need these tools. They're desperate. They are there to save lives now. But we also need to use them to trigger imagination and to have these discussions among technicians, because it is health projections in hospitals that need to be fed with this information. But it's also the imagination of people in government that need to have the courage to act. And actually also the courage to make mistakes once in a while. Because I was confronting them. There's also 40% chance that this is not going to be 40 degrees. And if you've canceled this event, a lot of people are going to be very angry at you. So you need to be ready to also explain in your responsibility how this science is giving you probabilities, and you need to act on it sometimes, and you can have done the right thing and saved a lot of lives, but once in a while you'll be wrong. And we together, the mayor and me, at that point need to stand up together for this science. And that is also a trickier thing, maybe another reason why we need to have this European project together, because that science is actually also under attack. And I know what would happen if we would be in the 40% and we would have cancelled an event. That would be the climate scientists trying to run their scare game once again. and we would be facing bad headlines. My minister would be in parliament. So that's also where we need to do the science in a way that has that dialogue as part of our preparedness. And once again, that is so much stronger if we do it not just in Amsterdam, but in the whole of the Netherlands, and not just in the Netherlands, but in the whole of Europe. And if we build that confidence together, but also those dialogues together. And once again, I was very, very excited by the way this is now coming together in the European Parliament, and frankly, in the European Commission between the different DGs. And that's something we still have work to do across different departments in the Netherlands as well. Just one other example. I was giving you most of the examples about saving lives. One big challenge for us at the moment is electricity net congestion. So we have started to make a big shift towards renewables. We also have a big ambition to build many more houses. We have a housing problem in the Netherlands, and ability to connect those houses to enough electricity is one of the stumbling blocks now enabling this housing ambition that the current cabinet has. The net transport company, TenneT, has a big challenge at the moment dealing with those new peaks in renewables. And they are managing that conservatively in a right risk management way, right? They want to be sure that when they connect houses to the grid, they can count on their electricity at all times. But actually, it's difficult sometimes, you know, and we have these destiny simulations sometimes. In this case, it was a storm, and at some point you get a cutoff. I don't know if you saw this example in one of the workshops already this afternoon. It can also be what we are now actually, I showed you that report of the plausible weather extremes that could hit us today. We had a plausible weather extreme that actually in our weather room would have been one of the dullest periods in the year, when there would be no wind and it would be a very dull gray sky in winter. But when all that electricity generation then falls down, it would probably be a fairly cold period in winter as well. So especially also with more houses now being heated with heat pumps, you actually need a lot of electricity. So those are the moments that they suddenly have a problem. Better use of this intelligence on a climate timescale and on a weather timescale, and possibly also making deals with companies. What if we supply you electricity with 98% certainty and we can switch you off at certain days in the year? But we'll give you some advance warning on when that would be. We can provide you electricity much more cheaply. Well, we might be able in some cases to connect up to 20% more houses to the same grid and meet those same highest profile political challenges together. Again, once we imagine how this information needs to come to the fore. It requires me talking to the CEO of that grid operating company. It requires both of us to touch the right political buttons in the government to start to make things happen. It requires change of regulations sometimes. And in the end, it also requires the nitty-gritty data spaces that were presented here so beautifully on screen before to come together and to enable the electricity grid operators in her company, the meteorologists in my weather room, to work together and use all this digital intelligence when it matters. Also when that storm is coming and they need to act smartly at a timescale of seconds. Here's some, I'll, in light of time, skip this. I don't know if you see these examples, redesign of wind farms. There's so much more we can do with this type of intelligence that will get us further. And finally, I was mentioning that this is not just a game for saving lives. This is a daily reality in terms of, well, for instance, the heat waves that I was mentioning before. We still, after that 1953 disaster, the other two disasters at that same scale of magnitude of mortality were both heat waves. And the Netherlands is still laughing about heat waves at times. So these are life-threatening situations where we're using the Destiny intelligence. But it's also an economic case. And this is actually, it looks a bit funny, but it's the AAA is from the AAA rating that we have for our investment climate. And Dutch banks and insurance companies are concerned about the way our ratings might be affected by changing climate conditions and changing climate extremes in the Netherlands. And they are concerned about the way in a European competitive landscape the rating agencies will be judging that. And so, for instance, decisions we'll be making about the European climate scenarios and the way they will be applied also by central banks will make a huge difference to the economic investment climate in the Netherlands. And getting these financial sector investments right, getting the data combined with the way financial risk is being judged, and then in the end feeding into the right decisions on how we manage risk, is, I think, one of the keys that where we again can unlock so much potential of Destiny. It's a set of dialogues. I was in a podcast yesterday with the head of climate of the European Central Bank. I don't think my predecessor actually talked to central banks in his whole term, because we thought it was a sort of natural handover that might happen with people just picking up our data. It's something we need to work hard on. And once again, Destiny is making that possible. So finally, my key pleas here: there's no way we can no longer blend weather and climate. We have to blend physical and AI models. And we need it with trusted sources that can talk the talk at these different levels in co-creation with users, where again, we have these chains, but we need to work hard to make them a reality. Thank you very much.
Martin, thank you as always. That was fabulous. There's so much provocation, food for thought, and I hope inspiration for all of you who carry these conversations forward into your workshops and your meetings tomorrow. I was particularly struck by the links with health as well, because although it is not a European story, I read an article, I think yesterday, that the US federal public budget for the World Cup, which starts on Friday, is about $650 million. $0 going to health or public health. So there are no preparations for heat-related overpopulation of emergency rooms or heat domes and how that would affect people traveling. And there's also no anticipation of very hot conditions and virology viruses, infectious diseases and the like. So, yes?
If you want to know more, we did a fascinating attribution study looking at the, I think my mic is off already. There's really interesting science on this. For those really interested in the...
Try this one.
Got me there, just wanting to promote a little bit more science. There's fascinating work by the World Weather Attribution Consortium that's looked at the chances of heat problems affecting health during the World Cup. Great science, so those of you interested in meteorology, climate science and the links to health, I can recommend some really interesting reading, fresh off the press and exactly relevant to this. So just find me over drinks if you want to know.
Very good. Well, okay, it's time for us to wrap up. It is indeed time for us to have a drink, as Martin says. So before we wrap, we're going to do a photo, number one. Not going to let you escape from that quite so easily. Second is just also to thank the online audience who have been following for quite an extended period of time. We all know it's not easy to do this behind a screen, but hopefully these discussions on stage have been illuminating and engaging for those watching online. So please give our online audience a round of applause, because it's not easy. Okay, penultimate thank you for being here and for your engagement and your patience and your attention and for helping us to keep pretty much on time, which is always one of the key success factors, not quite at the same level of what will define the future for Destiny, but it's always good to end pretty much on time. And so I would just like to thank